Hi friends, welcome to another episode of Decluttered. Let's have a look at this integration question. Pause this video for a couple of minutes and come back to us for the solution.
Okay, I'm sure you guys must have seen the sum and been like, okay, what's the most complex way we can solve it? But if you look at it, you can break this down and use integration by parts. You guys obviously know the formula for integration by parts, right? So let's just take the rule first, which is ILATE. And obviously this stands for inverse trigonometric functions, logarithmic functions, algebraic expressions or functions, trigonometric functions, and exponential functions. So when you look at this, right, what can you see? Obviously we have our inverse trigonometric function here. So you take this as f of x and you look at this, right? It's an algebraic expression. So this becomes your g of x.
And now I'd like to pause here for a couple of seconds and just understand the smart thing that has happened in this question. Sine inverse x, the differential is root of 1 minus x square, and if I have 1 minus x square as t, the differential of that is minus 2x. So the catch here is whether to use root of 1 minus x square with sine inverse x or root of 1 minus x or the x with root of 1 minus x square. And you have to very strategically, like Rusheel has used, use x by root of 1 minus x square as one function and sine inverse x as the other function, following the principle of ILATE.
Thank you, sir. So now that we come to the actual solution itself, so our integration by parts is f of x, g of x. So f of x integral g of x dx minus differential of f of x integral g of x dx. So just simply substitute the values. F of x is sine inverse x, x by 1 minus x square under root dx, minus d by dx of f of x. So we know that the differential of sine inverse x is 1 by under root 1 minus x square. So the same term basically without the x. And then of course integral, you take your g of x, which is x by under root 1 minus x square. So now we have to solve this integral. So I'm just going to move this here. So let's just take it as I equals x 1 minus x square dx. So when we take a look at this integral, right, what can we see? We can see that if we take this as t, we can easily find x dx, or we can find it in the dt by t form. So what I'm going to do is I'm going to take 1 minus x square as t, and I'm simply going to differentiate both sides. So this is going to be negative 2x dx equals dt. I need to find x dx, right? So what can I do to this expression? I can just send the minus 2, that's it. So x dx is going to be dt by 2, and don't forget the minus sign. So you can write this as I equals negative 1 by 2 integral. This I have found to be my dt. So I can simply write this as dt by under root t. We get I equals, we can take this as negative 1 by 2 integral t to the power negative 1 by 2 dt. So by integrating this, we get negative 1 by 2 times t negative 1 by 2 plus 1 by negative 1 by 2 plus 1. And let's just get this here. So we're going to get negative 1 by 2 times t 1 by 2 by 1 by 2. So our 2 and 2 is going to cancel, and we're going to be left with negative root t. So this is the value of I, right? And let's plug in our value of t, which we've taken as 1 minus x square. So it's going to be negative 1 minus x square equals I. So let's just get this a little here. Sir, could you help me with the rest of the expression?
Sure. So while Rusheel has done all the heavy lifting, just filling in the formula, we have sine inverse x into minus root of 1 minus x square minus integral 1 by root of 1 minus x square into minus root of 1 minus x square dx, which is equal to minus sine inverse x root of 1 minus x square. This minus and this minus will make it plus. This and this will cancel, and I have plus integral dx which is equal to minus sine inverse x root of 1 minus x square plus x plus c. And that is the final answer.
And we've successfully decluttered this sum.